This meeting is being recorded.
All right, so welcome everybody. This is the Listnet Cio Group. The group overall, we have about 50 members. Before COVID, we were meeting about once a quarter. It was in person. We've had a few Zoom meetings during COVID that have worked out well. We are working on an in-person luncheon for April 28th that I'll send everyone details on with CompTIA. And that's going to be on a very important topic, which is the talent pipeline and how we can better make connections and keep that strong in the local area on Long Island, but just in general overall, because that is a challenge that I hear from the other companies in Listnet that, you know, recruiting and all that. And as some of you know, aside from running Listnet, I also have my own company, so I'm dealing with that as well. So we're going to do a special event on that. And then we'll get back to kind of doing in person, but we'll probably have the ability to people to come in virtually via Zoom on that also. So I want to introduce our speaker, Mike Piech. How do you pronounce your last name, Mike?
Piech, yep.
Piech, perfect. Okay, so Mike Piech is VP at Red Hat and manages their VP and General Manager of Cloud Data Services. And one of the topics that people have asked for multiple times has been AI, machine learning. And I thought it would be good to put together something where not just learn about those things, but how can you leverage them to make what you do or make your jobs a little easier. So Mike, please take it away.
Great. Well, thanks very much, everyone, for having me. Really appreciate the opportunity to get in front of you all, share a little bit about what we're doing here at Red Hat. And the point here, to be clear up front, is not trying to do a fancy sales pitch or something like that, but rather share some of the open source work we're doing. I'll touch on some of the products and the offerings, but it's as much to just give a sense of how the industry is laid out and what some of the trends are. And, if anybody's interested in going deeper on any of the things that we touch on here, happy to sort of do that follow up and get that organized through Paul and the gang here. So I also wanted to take a moment to introduce Stephen Huels, who is on the team here. Having him join me was a great opportunity. Stephen has been in the, he's been in data science since long before it was called data science, back when it was called things like analytics and so on. So Stephen's got a background at SAS, among other companies, has been at Red Hat for at least 5 or 6 years now, and has really been the shepherd of a lot of the technologies that we're going to talk about here. Was there a question? Sorry. Oh, sorry. I thought I heard an interjection. So the other sort of two more upfront notes. So we're going to come at this from a couple of different angles. We're going to talk about how with platform level enablement, we enable enterprises to do data science, to develop applications that incorporate artificial intelligence, machine learning, et cetera, into their applications. There's in addition to that, an angle of how one uses AI ML to augment, to enhance the automation of infrastructure management. So I'm going to touch on that a little bit, and I'll say that there's another business unit at Red Hat that is responsible for those technologies, and I'm not an expert there. Stephen can probably go further than I can on that, but if that is of interest for a deeper dive, we'd be happy to get folks from that business unit to jump onto a future one of these gatherings and share some more detail. But there is some super exciting activity going on in that space. So I wanted to just put a couple of slides of teaser in there, because I know that the topic, as originally kind of articulated for this particular gathering, the theme touched a lot on that sort of automation of infrastructure. So with those setups, bear with me while I remember how to get a share screen going. And also, to be clear, let's see.
Green button at the bottom. There you go.
And okay, so you guys, are you seeing a slide now?
Yes.
And let me put it in slideshow so it fills the screen and some of the
good
more detailed slides come through. So we're good here?
Yes.
Excellent. Okay. So again, I run a business unit here at Red Hat focused on higher level services above the platform being, Kubernetes, in our case, Openshift. There are a number of services that Red Hat offers on top of that to help application developers wrangle data, accelerate their application development, and so on. The area that my business unit is focused on, and in particular Stephen's area, are sort of tools and partner capabilities to enhance how data science in general is done in a Kubernetes environment. So hence the kind of the topic, the title, and the theme here. So just to really do the ridiculously high level summary, it's clear that AI and ML are increasingly being adopted out there among enterprises, and we'll see in a few seconds just how comprehensive and sort of horizontally applicable some of those capabilities are. But there are some important challenges and considerations to take into account as you're planning, as you're thinking about how to incorporate these technologies, how to leverage them, how to enhance, your competitiveness, et cetera. And a takeaway that I hope everyone will take from the presentation and even more importantly, the discussion, the interaction we will hopefully get into is, start small and build out from there. One of the key advantages of Kubernetes and containers and the microservices way of architecting applications is that incrementalism is not just a possibility, it's a desired way of doing things. And that ability to take small steps, engage in a lot of trial and error, and gradually build out to a comprehensive solution without getting just completely snarled early on by trying to do too much at once, trying to boil the ocean, is really an important takeaway theme here. So we'll look at the potential and challenges a little bit. We'll go a little bit more into what it means to do AI and ML in the particular context of containers and Kubernetes. Talk about a couple of things that Red Hat's doing out there in the industry, along with partners, to be clear. And then we'll just highlight a couple of ways to sort of dive in and get going if you're not already down the path, as it were. So clearly the potential is huge. And before even throwing up the usual kind of bevy of analyst numbers that characterize just how big things are, I wanted to get a couple of quick terminology things kind of level set for all of us here. Because the terms all get bandied about almost with in some cases some sloppiness, and we want to be clear about that. So artificial intelligence is the outer encompassing category, and not all artificial intelligence necessitates learning or is necessarily based on learning. There is kind of top-down knowledge engineering, as was the sort of much earlier term, back from when the era of some of these textbooks, back when I was a computer science undergrad doing artificial intelligence. Machine learning is the specific subset of artificial intelligence that involves training and models, right? And as we'll see in a moment, data is a super important part of that. In order to develop intelligent apps, to have what is credibly, visibly, tangibly seen as intelligence, involves training with massive amounts of data. And then deep learning is a particular subset of machine learning where, as opposed to simpler, let's say, linear regression or some of the most basic models, you have models that are many, many layers deep. And these are the models that can learn really complex distinctions, right? So classic examples are things like image analysis and the classic finding the kitties in the pictures and that sort of thing. So anyway, hopefully everybody's clear on that. I don't want to belabor it, but just wanted to level set there. But as I mentioned, in order to do this at all, in order to get usefully intelligent applications, one needs a lot of data to train and come up with models that work. And so a theme that we're going to ease into here is that much of what doing data science and doing AI and machine learning within the context of enterprise applications is way less about the actual inner core of which algorithm is used, what kind of model is used, and what the data scientist does in the Jupyter notebook. It's all of the plumbing and all of the data engineering and infrastructure setup around that to get to the right data to the right place at the right time so that the data scientist can do his or her thing. And then to take the artifact, the output of that work, and have it smoothly publishable into production and iteratable and life cyclable and monitorable and fixable over time. So that is a really important thing to keep in mind. It's easy, and if you Google around and look at a lot of the discussion about AI/ML, there's a lot of really fun, interesting, cool rocket science around algorithms. But the grunt work of setting up all the data plumbing is really where a lot of the time, effort, and money goes in making AI/ML viable in the enterprise. So just by way of just a sprinkling of use cases, just to, again, calibrate everyone as to just how widely applicable these capabilities are. Healthcare, things like diagnosis, right? So automating, let's say, looking at X-ray images and saving the need for expensive doctor time to do analysis and taking that, using that analysis offline in a model training exercise so that expertise can be leveraged through a machine learning model, much more, broadly across the geographical footprint and in a self-service manner is an example of where learning is dramatically overturning an industry. Financial services, many different aspects, risk analysis, fraud detection, the ways in which learning are being applied to improve those areas, to accelerate those areas, massive, right? On the telco front, network optimization, right? So software-defined networks and sort of reconfiguration based on learning through patterns. Lots of interesting things going on there. Insurance, the raw, massive statistical analysis that goes on for the actuarial sciences is an area that is certainly ripe for automation with learning and reducing the need to have so much sort of human sort of analysis and poring over massive spreadsheets. And then, automotive, there's lots of eye candy out there in terms of autonomous driving, and even below pure self-driving cars, just the ways in which learning just augments, traditional manual driving, right? Whether it's, sort of keeping you in your lane or warning of issues, making preemptive moves to avoid accidents. So anyway, just a sprinkling. Here are just, across the usual suspects, Gartner, Forrester, IDC, 451, there are all sorts of massive numbers characterizing the opportunity here. So, one of these guys is saying, 13 trillion, the potential to deliver additional global economic activity by the end of 2030. 50% of enterprises, and as a challenge in the face of that opportunity is that 51% of enterprises are saying that their current infrastructure will not be able to meet the needs of the applications and in general the functionality implied by that opportunity. And much of what that 50% represents is the inability to handle the massive amounts of data that it takes to train models and the infrastructure that it takes to actually life cycle real models in production and to have all the security, the reliability, the fixability, the data provenance and all of the legal and ethical issues that arise from when learning is used to come up with a decision that affects somebody's financial situation or their health, etc. So lots of concern and angst around that for sure. Another important point, so as Red Hat, of course, we can't talk about anything without mentioning the importance of open source. And frankly, irrespective of Red Hat, the way that AI and ML and data science more generally have evolved in the industry, in the market in general, has been massively not just influenced, but really driven by open source. Many of the packages, let's say, used in machine learning, like PyTorch and so on, have come up out of open source efforts. Many that started out as proprietary. So let's say some of the things that Google has put out there, they started out as internal Google projects, and then Google went and open sourced them. Things like TensorFlow, things like Kubernetes itself, which is not AI per se, but which is, as we'll see, a substrate, a platform on which to carry out AI and ML and augment applications with it. And furthering this point of, it's not just about the model, it's not just about the data scientist and that fun work training models inside a Jupyter notebook, but both the upstream, the data preparation and data ingestion and feature engineering and those aspects, as well as the downstream, the actual inferencing or using of models in production, and the way that a model artifact gets published and again managed, are equally important in terms of their demands on infrastructure. And recent survey here from 451 shows just how evenly distributed the expectation of requirements and demands on infrastructure is across those three sort of macro stages of the process. So let's just quickly go into a couple of the challenges. First and foremost, everybody's aware of the talent shortage. There aren't enough data scientists out there, and anybody who's got AI, ML, or data science on the resume, just add a zero to their salary expectations. We ourselves at Red Hat are, part of that as we, compete for the best talent to do what we do in AI, ML, and as enterprises and various government and other types of organizations out there, I'm sure you experience some of this as well, to the extent that you're already down the path trying to do AI, ML. And so given the talent shortage, that has a couple of implications, right? You want to make data science capabilities accessible to a wider range of folks. You want to sort of reduce the dependency on those very rare skills, those very sort of rocket sciencey PhD level skills, and essentially democratize the ability to incorporate AI, ML into your various projects, your various application development efforts, your infrastructure automation efforts, et cetera. And that's part of what we're trying to do, what we're trying to bring to the market. And sort of in that vein, so self-service is a super important aspect of that democratization. Now, there are certainly ways that, let's say, developers in your existing development shops can kind of go out there and read tutorials and go into their Amazon AWS accounts and experiment with SageMaker, or go into IBM and play a little bit with Watson, et cetera. But it's daunting. It's complicated. I myself regularly go into those things and stay current with how the technology works. And I got to say, it's all of this kind of textbook worth of stuff in your head doesn't make it any easier to get in there and really sort of pick this up in a half a day or something like that. And then as I've already kind of hinted, and I just, it'll be a recurring theme here, operationalizing the results of initial data science work is often the place where enterprises stumble, right? So a couple of the ambitious and let's say, more talented of you developers may really successfully go in and, let's say, on Microsoft Azure, get really competent at setting up models and training models to in a proof of concept type of project, demonstrate how much better you can make, for example, a customer service application. Now the question is like, how do we get that into production? So I've got my regular application development engineers over here who build, a traditional application. I want to augment it with this model. What's the workflow that brings those artifacts together, versions them, make sure that they're compatible, gives us that sort of all that sort of reverse, back out capabilities in case something goes wrong. The folks on the operations side of the house who actually have to then go deal with this combined entity, what knobs and dials are presented to them to make their jobs, viable as their pagers go off at crazy hours. And so there's a complexity around the operationalization that needs to be taken into consideration. And just put a finer point on that and give a little picture, right? So here is just a simplified kind of subset of the main personas, right? Your data engineers, data scientists, your machine learning engineer, right? The more traditional app developer I was just alluding to, and then the ops folks, actually running the stuff in production. And we look at their involvement over the life cycle of creating an application that incorporates a model, right? There are a lot of different moving parts and a lot of different handoffs and interactions between different types of personas who don't even necessarily speak the same language. Okay, so let's talk a little bit about what containers and Kubernetes bring to the table here. There's both opportunity, but there's certainly complexity too, as those of you who are already down the path with containers and Kubernetes, whether it's Openshift or any of the other ones out there, that it takes a while to get your head around life as YAML files and thinking about how to manage your application estate by writing descriptive YAML about what you want the state of the world to be, throwing it at Kubernetes and then having Kubernetes magically figure out what to do to realize that state. It sounds great, and it is in many ways a very powerful way of thinking about and actually managing applications at enterprise scale. There are aspects of that get daunting, right? But in general, what containers and their lightweightness and their horizontal scaling capabilities and their easily replicable packaging capabilities bring to the table are agility, right? And a lot of that is engendered by that incrementalism I mentioned earlier, right? The ability to structure applications as aggregations or composites of fine-grained pieces, each of which can be dealt with in somewhat isolation and incrementally updated lifecycle, et cetera. Portability, right? So to the extent that Kubernetes out there are consistent platforms, you can move applications around, and this is where we get our notion of open hybrid cloud, right? You may have some workloads on your on-premise or traditional data center infrastructure. You may have some in hyperscaler public clouds. You may have a combination. And the flexibility is kind of intertwined there with the portability, and then scalability. When you start to design applications where the choke points or the potential bottlenecks are structured in a way where they can be where those bottlenecks can be augmented simply by throwing more instances of the same thing into the mix, that's where you can really enjoy the benefits of Kubernetes automatically scaling up and scaling down as load varies over time. And at this point, through one survey here, I think this was also 451, 94% of AI adopters in enterprises are expecting to use that AI, to deploy that AI in a containerized environment. So the emerging architecture for doing AI ML in the enterprise in this context of Kubernetes and containers and microservices and DevOps and all those interrelated kind of architectures and concepts and technologies looks something like this, right? So you have your top level tools that the folks doing the machine learning and app building need, right? So your Jupyter notebooks with your TensorFlow and Python language support and so on, right? So those are the top level things that are specific to AI and ML. To make those things work, you need underlying plumbing to get, as I've said before, data, from disparate sources to the right place at the right time, so that whether it's the training piece or the inferencing piece can be carried out at the scale and with the performance, with the latency, as appropriate for whatever the application domain is. And so underneath that plumbing and those higher level concepts and technologies is the container platform, right? The layer of platform that manages the containers, orchestrates, automates. And then that sits above traditional hardware and specialized hardware like GPUs and tensor processing units, that if it's done well, as Kubernetes and certainly what we believe we've done with Kubernetes in the context of Openshift, makes the idea of seamless platform spanning heterogeneous underlying infrastructure a viable approach. So a little more on what Red Hat is doing in the context of that general architecture just laid out here, right? So we have, as already mentioned, Openshift as our instantiation of this hybrid cloud platform, right? The Kubernetes orchestration of Docker containers. We also have capabilities to help with the data wrangling, right? So we have, with our Openshift Data Foundation, which is now part of Openshift itself, that helps add a software-defined or software definition layer to handle all that big and highly invested storage capabilities that you might have in your data centers. We also have some newer, let's say, integration and other sort of data plumbing capabilities that were spawned out of traditional middleware, right? So things like messaging platforms and modern container-based incarnations of patterns such as the service bus. And then, finally, we've got the capabilities enabled by the underlying operating system in Red Hat Enterprise Linux. And for those who are down this path, and this often is in the context of telcos, the OpenStack infrastructure as a service capabilities. So let's look a little bit more closely at machine learning ops with Openshift, right? So at the moment now, we're not even talking about AI specific things like models and training per se, right? This is just the plumbing to be able to take a model as a black box artifact, right? Irrespective of how it was created, and just sort of manage its flow, its workflow from initial training out to deployment. And there's one technology called Tekton, which is a workflow for just that kind of managing an entity through a sequence of activities and ultimately arriving in a registry, and that's our Quay technology. So that's part of an architecture where you're publishing models in an enterprise grade, reliable, secure, life cyclable fashion. And then you've got the monitoring and the sort of the ongoing life cycling and improvement and tuning of models. And that's in a way a different flow needing different types of workflow capabilities. And that is powered by GitOps and sort of tying into the various sort of GitHub capabilities, and also based on an open source project called Argo. Now, moving up a layer, so just above the plumbing, but getting into now, okay, what are the things that the actual data scientist cares about, right? There are Jupyter notebooks, there's TensorFlow and PyTorch, which are two widely applicable and probably the most popular machine learning frameworks and model styles used out there. Sometimes those are run on Spark, which is a way of doing sort of a variant of MapReduce, the sort of massive distributed processing and then aggregation of the results of that distributed processing. These capabilities, and this is where Stephen has been the lead here at Red Hat since its inception has been carried out in an open source project called Open Data Hub. And a quick additional note on that, the idea of Open Data Hub is not to itself be a new model or be a new way of doing things. It really is an aggregation of these existing popular best of breed open source technologies out there. It brings them together into a coherent, seamless, dashboard, user environment, user experience to create an end-to-end workflow for doing machine learning enhanced applications, trying to make progress towards that, as we said earlier, democratization of machine learning and AI, enabling better handoffs, more seamlessness between, let's say, the data scientists and the application engineers. So that's the original charter goal mission of Open Data Hub. And before that became productized, which we'll get to in a little bit here, it was an open source project that has been nurtured out there by folks in the community, some Red Hatters, some from other companies, and just in the classic open source community sort of way. What we have developed over the years is a reference architecture around that technology, that open source technology, which we've used extensively in customer engagements, whether with, let's say, partner development houses or our own consulting efforts. We've used this Open Data Hub technology and supported numerous use cases across many verticals, right? So, healthcare, automotive, telcos, some of the ones that I mentioned in that earlier kind of survey of use cases out there. And again, to re-emphasize that this is not, all about Red Hat and it's just Red Hat and a walled garden and come buy all of our stuff and we just do everything for you. Very much our approach, both as an open source company and open source community catalyzer, and then also just as the way we do business, we enable a wide ecosystem. And when it comes to AI ML in the enterprise, that ecosystem is vast, right? If we just look at the categories like the life cycling tools, the data wrangling tools, the databases, the infrastructure itself, governance and security, analytics, AI ops, and emerging sort of subsector here. All of these things are you see some company names spanning multiple ones of those categories. You see some company names that are only laser focused on one subset of that whole area. Now here's where I wanted to take a quick jump to looking at this problem from a completely different angle. So there is, how does one use AI, ML in the context of infrastructure automation, right? So all of those tasks like, provisioning systems and scaling and error, or fault remediation, et cetera. What does AI bring to the table there? So Red Hat, a number of years ago, acquired a company called Ansible and its associated open source based Ansible management and automation platform. So that's one of the major offerings of Red Hat. And again, developed in the open source arena and contributed to by many non-Red Hatters out there, but brought together and productized as an offering by Red Hat. And, I don't want to go into all of the specific capabilities of an automation platform and the differentiators of Ansible itself, just a kind of a quick level set here that we do have this offering. And just to be clear, what all that, what all is comprised in that, what capabilities we're talking about. So you've heard phrases like infrastructure as code and the CI/CD. Not just of applications, but of the underlying infrastructure to support those applications, right? And GitOps and things like that. So this is all supported by Ansible. Ansible has an understanding or internal representations of various types of networks and network entities, and the ability to automate the configuration of much of the underlying network infrastructure. It is used to do provisioning, configuration, and compliance checking in a hybrid cloud environment, right? So it's not just run it only on your, let's say, on-premise estate, but then you have to go switch to some different management console to go deal with your different cloud estates. The idea here is to manage everything from a single pane. Security is super important for practically any enterprise out there, and there are numerous security-specific capabilities. And then just that raw underlying deployment, provisioning, monitoring, management, cost evaluation, cost optimization, et cetera, right? So these are all the kinds of things that Ansible does. Now, an area of active development right now is further expanding, enhancing, improving all of those capabilities that I just laid out by using learning, by using various types of, whether top-down engineered knowledge or bottom-up sort of learned on the job type knowledge. And this category is an emerging category out there in the marketplace called AI ops, right? So this is many of the automation technologies out there are trying to augment their automation capabilities in various shapes and forms with the capabilities that we've been talking about here. And so I want to just, now this is a totally, early preview. You're probably all well aware that Red Hat was acquired by IBM, and now we've continued to operate as very much an independent entity, which has been great. IBM has been fantastic in allowing us to continue in that autonomous sort of business model and allow us to do our thing in terms of the open source community and so on. All that said, it has been really great how we've been able to get closer partnership with various parts of IBM and find some really fantastic synergies between some of their technologies and some of our technologies. Now, Red Hat technologies are and will be for the foreseeable future pure open source, right? That is our way of doing things. But that doesn't mean that our products aren't used by our customers in conjunction with other technologies that aren't necessarily fully open source. And that's fine, and that's awesome that there is that ecosystem and that flexibility. So long-winded backstory to, there are a number of initiatives, a number of efforts underway where we're using different combinations of Red Hat technologies and IBM technologies to create grander solutions. And this notion of AI ops, this notion of bringing intelligence and learning into the world of infrastructure automation is just such an area, right? So we have our Ansible automation platform used in conjunction with IBM's Instana observation and validation technologies, their turbonomic capabilities around ensuring that the infrastructure configuration is optimized, and that sort of continuous sort of reallocation of resources to make sure that the best possible efficiency is being gotten from the resources at hand, and then combining that with IBM Cloudback for Watson AI Ops. Now, IBM Watson is one of the technologies that is part of the Open Data Hub effort. So this ties nicely into the development environment that I've laid out a few slides ago, where you can use that Open Data Hub based environment in conjunction with these technologies in Ansible to really work up a learning based further enhanced optimization of your infrastructure. So this is work that's in early stage, right? So we've got the teams have sort of experimented with setting up these combinations and working through the playbooks, the reference architectures, the sort of the how-tos, and making sure that any sort of rough edges or existing seams are smoothed over. So look for this as an area of just incredible advance in the coming months and even over the next couple of years, right? As more and more of that learning capabilities is conjoined with underlying automation capabilities. So last thing I want to touch on here in terms of what Red Hat's doing out there is an offering called Red Hat Openshift Data Science, or RHODES as we affectionately refer to it. This is a managed service, so software as a service, a SaaS offering based on that Open Data Hub technology. And this is representative, by the way, of a whole new direction for Red Hat, where traditionally we have offered all of our products as, traditional bag of bits, right? Traditional piece of software that you download, you install, you self-install, you self-manage, etc. We're increasingly ramping up offerings and capabilities where we manage it on your behalf. So just like going to, let's say, Amazon SageMaker or any of the many services in Microsoft Azure or in, let's say, Google Cloud, you come to console.redhat.com, you log in, you sign up for certain services, you deal with them through an exclusively web-based user interface across the net, and you're not on the hook for doing any of that installation or that low-level configuration. Much of that grunt work and those areas that are rife with opportunities for error and which are hard to scale because they're just raw human effort. Much of that is automated under the hood for you. This offering is in what we're calling field trial right now, so it'll go into general availability, so fully sort of for fee and supported and everything in the order of a couple of months here. In this stage of field trial, just to be clear about what that means, it is fully enterprise ready, fully tested. It is fully supported with top tier SREs. So as you get into using any of these capabilities, any of the functions such as the Jupyter notebooks, the source to image builds, the NVIDIA GPU acceleration, you can rest assured that you won't be left high and dry in terms of enterprise level sort of operation. The only difference between field trial and full GA is that we haven't yet put that guaranteed life cycle on the product, right? So once we flip the bit to GA, you'll have that sort of traditional part of what you pay for when you get something from Red Hat, that guarantee that software that you've signed up for will be supported through some number of years of life cycle. So that's the difference between that field trial and GA there. Again, I highlighted, in addition to the Jupyter notebooks and so on, we have a couple of the partner technologies such as Starburst for the distributed SQL queries, and kind of think of it as data virtualization to help with pulling in data from disparate sources to train models. And then on the model serving side, we're working with Selden there as well. And there are other technologies from IBM, from Anaconda, et cetera, that are also, I mentioned IBM Watson. And then we've got a long list of more partners that are already working with us to greater or lesser extent, and whose incorporation and even better seamlessness we're working on every day. So there's a lot of investment and a lot of development and a rich roadmap in this area. So that's about 45 minutes here, which is about what I was hoping to do so that we can get interactive here. But just to revisit that first slide, lots of opportunity, some challenges that we walked through here. Hopefully we gave you a little bit of a sense of some of the things that we're doing out there in the community, the open source world, and with our own offerings to help you get started and really start to bring some of those possibilities into your various organizations as represented here. So I'll just pause on the last slide here with some resources, and I'll happily make the deck available so that you guys can look at this later. So you can either take pictures of it now or don't sweat it too much, because we'll share it and make it easier for you to just click the links. but there is a wealth of information that Stephen's team, as well as other folks such as the Ansible BU, have created to get you going out there. So with that, let me go ahead and stop. And we've got we've got Stephen Huels on the line as well, and he and I are happy to just dive into wherever you all might want to take things. And thanks again for the opportunity to get in front of you. Really appreciate the chance to share a little bit here about what we're doing.
Thanks, Mike. That was great. And if you email me the slides, I'll get them out to everyone on the call. Great. And those that are not on the call even. Yeah, so let's open it up. Does anyone in the group have any questions, or is anybody using AI or machine learning already?
Hi, this is Joe Marquez. I've got a question. Mike, thanks for the presentation, very informative. And I get the premise, or at least I think I get the premise, that architecting through containers gives you a lot of the benefit as well as the flexibility to architect your solution in any number of ways. Are there any case studies where people have migrated their early start environment from one architectural and infrastructure setup to another, and we're able to just keep scaling and evolving in that direction? We too are starting small. We've got an application, actually a product, that's coming to market now, which is just using some basic AI just to be able to help out users in what I would consider to be one of the simplest use cases you could imagine. But you know, all AI engines start out stupid, and eventually over time they get smarter. And as ours gets smarter, we can't anticipate where this is going to go. So are there any case studies of people who started in one environment, migrated to another, and kept on running as opposed to going back to square one?
Stephen, that sounds like a perfect question. Stephen's been involved in a number of the customer.
That's a great question, Joe. Because again, like AIML didn't start with the invention of containers, right? There's a lot of this stuff running out there on like bare metal systems, a lot of them running in VMs. And so like I take it in a couple of approaches. And actually, if we actually do have a workshop we run with customers that can actually help you migrate like a set of AIML into containers as well, if you want to see us actually walk through it. A lot of this, like depending on the nature of the application, like you take it in phases, right? You know, not knowing your complete architecture. If your first thing you want to migrate over is, hey, let's just take the algorithms because maybe we need more resources for training and our container environment has that, or whatever. Red Hat does have a set of tools that actually can help with the migration off of other platforms, so it can do some of that automation for you. What we find is, like, for a lot of the AIML setup is, like, a lot of the biggest challenges are really just around the data scientists and the folks who actually put those original models into production, having them just learn how to build a container, right? Making sure you've got the right set of dependencies, requirements in there. The algorithm is still the algorithm, right? So if it's training off a set of data that's in sitting in a database somewhere else, that's still going to work. It's just some of the fundamentals of learning the containerized environment. And then from there, like, and honestly, like that takes about 8 hours for folks to kind of grok and like, oh, okay, like I get the idea from here. After that, the scale up becomes really easy. And that's where Mike was talking about it. It's, you know, it's one thing to kind of get that first model moved over, but then, like you said, these things get smarter. So you're going to probably want to do versioning of models. You'll want to have some pipelines that are doing like reproducing these builds as they get better and better. And so it really does allow you to grow, right? And in our world, Openshift gives you all that tooling to basically treat your models as if they were just regular code and applications. So you can use Git to version it. You can use pipelines and retrigger builds. You can chain these things together so that if like you need to rebuild your model, redeploy your app, all that can be orchestrated. But I think your approach is right. Like start with the piece you want to try to get into the containerized world, then kind of move the next piece, connect those two together, and then in the end kind of build the repeatability. And there's a number of materials out there. Actually, if you just search like Red Hat, I think it's /AIML, you'll see a bunch of use cases that walk through this. We've published a couple of white papers and done recordings of the workshop as well out there for how to do some of this migration.
Steve and Mike, thank you very much. Very helpful.
Anybody have any efforts that they've got underway that they'd love to sort of share, any just highlights or lowlights or medium lights of? I'm sure for the group here, it'd be great to just hear some of the activities you guys actually already have underway.
So I was a little cryptic in the way I phrased my question. This product that we're bringing to market was actually a challenge we received from a household name company. I don't want to mention any names, but their ticker is MSFT. And some of their client success managers approached us. They deal with some large law firms. And not one or two, but like a half a dozen or so CIOs said they get regular complaints, the loudest complaints from the professionals in their offices about completing a time card, something really mundane. They said to me, look, these are all Microsoft shops. They all use what I now refer to as X365 because they keep throwing more and more stuff underneath that. And as well as Teams. Was there any way to be able to accelerate what people, that understanding of how people spent their time, actually spent their time, as opposed to the way they think they spent their time, or the way their Outlook calendar suggests they may have spent their time? Is there any way to actually capture what's going on and yet give the individual complete control and autonomy? We didn't want this to be spyware or surveillanceware. We wanted to just make easy capture. The point is, not only can we say, okay, yeah, you spent 45 minutes in Word, we had to know what they were doing, what the file was about, what kind of actions were going on. So we knew that early on we could just observe what they were doing and then feed that to an AI engine. And to be able to say, okay, I get it. When I see you doing that stuff, it means you're doing this task for this client, for this case. And you know, how well is it turning out? Well, it's still early days. First round, for lack of a better term, is encouraging, but it's way too soon to declare success.
That's a neat one, actually. Ironically enough, one of the things, which is somewhat like tangential to what you said, but working with my team, we get a lot of questions in from like our field who's just learning what AI/ML is around like just fundamentals. So I spend a lot of my time like sending links and documents, like, you know, the things we have. And so we're basically building a model, and it's going to ultimately be deployed as a chat bot that basically applies topic modeling to everything we put out there. So it processes video, all the like documents, PowerPoints, all that kind of good stuff. So when people ask questions, we can generally like, kind of give them a, hey, here's some interesting material that might be related to it. But it also looks at, because all this kind of happens in the same set of chat rooms, it's designed to look back at other topics they've brought up, like leading into the question, to see if we can give them a recommendation as well. So kind of a context aware, here's the direct answer to your question, but it looks like you might also be looking for this. So that's an interesting problem space.
You know, kind of mundane, but it affects a lot of people. A lot of people who have to do time cards, and they all sit with their hands in their head in their hands at the end of the day on Friday and say, what the hell did I do this week? But we think this will be a plus for a lot of organizations.
Yeah, I imagine there's going to need to be some sort of tuning, and I would imagine that for individual employees to be comfortable with that, they're going to want some control over the representation of what they did, and getting that right, putting the right knobs and dials on, so that there's a, you know, just it keeps it below that sort of threshold of creepy and spyware. You know, that I got to imagine that would be a challenge in that use case.
Not to air dirty laundry, but we get some of those concerns from our own gang internally in our company doing that. And that's natural enough. We wanted to emphasize that people continue to have complete agency over the way they report their time. We're not building a timekeeping system, although clearly with all that data we could, but we're not trying to disintermediate any of those back-end products which are out there. We're just trying to make it more accurate and precise for how people capture their time, and then to give it to them in a report at the end of the day on Friday. And instead of wondering what the week was like, to show it to them. If they need to change it, change it. We've built in some exceptions where, not to put too fine a point on it, you've had somebody say, I don't necessarily want the boss to know that I spend the first 45 minutes on Monday morning updating my fantasy league stats. Okay. And so we give people the opportunity to put exceptions in that, whether it's a URL or certain kinds of activities. We want people, again, to have complete control, all the time, giving them tools to help them with the accuracy and precision of how they spent their time.
Yeah. And Joe, remind me, what's the business? What sector are you in?
We're a systems services organization. We're a systems integrator.
Okay.
And so we've got clients in the private and public sector. As we look at this particular challenge, it was first presented by law firms. Interestingly enough, a lot of non-lawyers harbor the suspicion that lawyers love to double bill, and in fact, they don't. Okay. If there's anything they hate more than double billing, it's underbilling. And they find that the imprecise way that people complete their time card now leaves a lot of money on the table. So the business case for this particular product is compelling, and the benefits recognition is immediate. And we said, it's not just lawyers, it's anybody who has to account for their time.
Great. So that sounds very interesting. And maybe I'll follow up with you after about having you do a presentation either for the CIO group or just one of our tech showcases or something. I think
happy to do it, Paul.
Yeah, that'd be a cool thing.
So this is Joe Giordano. So I'm local to Long Island. I'm also with Red Hat. I work closely with Paul. I'd be curious for the group, are there any organizations that are kind of struggling or they have use cases that might make sense to develop for AI ML, but because of the talent shortage or just lack of skills, or even just how fast the technologies are moving, they're finding that there's roadblocks to getting started?
Again, I don't want to monopolize the time, like to hear other points of view, but I find the biggest impediment is people not seeing a sense of possibilities. Okay, what can this thing do? What's possible? How should I think about this as a tool to deliver value? How do I, put some guardrails around my thinking so I don't think I'm gonna, put in 2 bits of data and all of a sudden I'm going to automatically hit the moon. It's that sense of possibility. We find enough content out there, if you will, to get people proficient to the point where they can start on the technology side. And they're not going to become experts unless they spend a lot of time as practitioners, not just students. So we find the biggest problem is people getting a sense of possibilities. How should we think of our solutions as incorporating this? I mean, on the analytics stuff, it's pretty straightforward. It's not much of a stretch there. But when it comes to other applications we're building, where does it make sense to incorporate these kinds of capabilities? It's getting people to think that way, I find the biggest challenge.
Yeah, I would say from my experience, and one of the reasons I wanted to have this session, a lot of people, at least in the local area, are not really tapped that deeply into these technologies, but I think they are very aware of the issues, whether it be dealing with these massive data sets, whether it be dealing with increasingly complex infrastructure. So I think there's problem awareness, and I think one of the things that I want to try to do through sessions like this and in Listnet going forward is make some awareness of the potential solutions of AI and machine learning. But I think we're early. I think we're at the start of it for some of the local companies.
Yeah, and I think the reason I asked the question was because one of the interesting things about this technology, and Mike said it early on, is all the innovations happening in open source, right? So it really reduces the barrier of entry to get started here, rather than where years ago where you had to make this giant investment to just start kicking the tires, right? So and to your point, Joe, a lot of times when we talk to customers, and my focus is across all the products, but my traditional expertise is more in the infrastructure space. And when we look at things like Ansible, it's really, we talk about the art of the possible, because there's really so many different things you could do with it and so many ways to reap benefits from it. It's really limited by the imagination of the implementer or the technologist.
So I want to ask, because first I'll ask in context of this and then in general, because I'm on the advisory board for Hofstra University on Long Island here. We're involved with NYIT and other schools. And one of the things we try to do through Listnet, which for Mike and Stephen, Listnet is essentially a chamber of commerce for the tech industry on Long Island, New York. One of the things we try to do is help the schools kind of add to their curriculum what businesses are looking for. We actually had some great success with NYIT, and they're going to adopt some of the Red Hat stuff, thanks to Joe and the team there. But it sounds like a lot of this stuff is geared around knowing Python. So Python is a good skill for students to adapt with TensorFlow and the Jupyter notebooks. Would you say that like that's one of the key skills of people to have, students coming out of schools?
I certainly see that. I'm curious if that's and Stephen, sure you can weigh in on that, but
yeah, what else would you recommend, Stephen? Python, anything else like that you would say schools should like start to teach their students?
It's interesting. Like I right now Python's the hot language,
yeah.
Right? So and then within Python, like the frameworks all really have Python variants, right? So whether it's TensorFlow, PyTorch, scikit-learn, they all have their advantages. They all have their special use cases that they apply, are applicable to. One of the things you can't but I'd say probably like 5-10 years ago, Java was also a really big language for integrating a lot of this stuff, and still continues to be, right? Like so I wouldn't ignore that. I say a lot of the focus would be on understanding the applicable use cases for like different model methodologies becomes critical. One of the things like we spend a lot of time talking to folks about as they're first getting into like putting their first AIML model into like an application, is that no matter what, like these algorithms will give you an answer. You put a data into it, you do the syntax correctly, you're going to get something out of the back end of it. And it may tell you that it's 97, 98, 99% correct.
Mm-hmm.
But if you don't understand the methodology behind what it is you've built, it may be that it actually isn't that accurate. And there are other ways to validate the accuracy of that model. And that actually tends to be the biggest gap. The frameworks have gotten to be advanced enough that really a lot of like your everyday developers can pick it up and can apply this. You don't need necessarily deep analytical data science skills to build a lot of this stuff.
Mm-hmm.
But it's understanding like, is what I built actually valid? Or am I actually going to cause some problems down the road? So when it comes to like what universities are teaching, certainly Python, we encourage a lot of them to use like get students familiar with like Jupyter notebook environments, right? That's the prevailing environment where a lot of this work is done. But then make sure they understand like the different types of algorithms and how to validate those algorithms and what they apply to, right? K-means doesn't solve all problems at the end of the day.
Okay, no, that's very helpful. Thank you. Anyone else in the group have a question? All right. I want to thank you guys very much for your time. This was very informative. Like I said, we're going to do an in-person event for the CIO group coming up. I'm going to post this video both for the CIO group people, but also for the general Listnet membership. We have about 50 people in the CIO group. We have hundreds of companies in Listnet, so I think this will be very beneficial. Like I said, I think in my view, this is fairly new, at least for many of the companies on Long Island, but I think in the next couple of years, we're going to see this climb in importance. So I think this was a very great topic.
Thanks for having us. Really enjoyed the opportunity to get in front of you and to hear a little bit about what you guys are doing. So thanks so much.
Thanks, and thank you, Joe Giordano, for helping put this together.
No, appreciate it. Thanks, Mike. Thanks, Stephen.
Thanks, everyone.
Thanks,
Stay
everyone.
warm.
Appreciate it.
Thank
Thanks
you.
again.
Thank you.